Welcome back everyone. In this lesson, I will introduce the concept of AI in a very general sense and start laying the foundations for the upcoming lessons. In this lesson, I'll try to get you comfortable with the fact that AI systems, as powerful and as capable as they may be, do not yet exhibit true human-like intelligence or sentient behavior in the way that some of the hype might lead you to believe. I'm also briefly going to introduce the three major ways in which machines learn. This is because there is one particular machine learning technique called reinforcement learning, through which the AI comes closer to mimicking human-like learning. It is this particular area of machine learning where some truly mind-blowing and groundbreaking possibilities are on the horizon. But this lesson will just be about laying the foundations. We'll start digging a little deeper in the next lesson. So what is AI? When we use the term AI, we normally use it in situations where the machines and software applications are able to mimic intelligent, cognitive, human-like thinking. And when I say human-like thinking, I mean the ability to reason, to learn, solve problems, detect patterns in information, and to generalize from them. Humans, for example, have the ability to visually distinguish between very similar-looking four-legged animals from each other. We can distinguish between foxes and coyotes. We can distinguish between Siberian huskies, German shepherds and wolves. And cheetahs and leopards are another good example of where intelligent thinking and careful discerning is required to distinguish between the two kinds of animals. Intelligent cognitive thinking is also involved when we are able to deduce someone's mood based on their facial expressions or by observing their body language. So whenever you see image recognition software that is able to identify different types of animals or objects or perform facial recognition on people where this human-like cognitive function appears to be mimicked, we normally refer to those software programs as being AI programs. In fact, image recognition software can be even better than humans at analyzing computer tomography or CT scans of the chest to detect lung cancer. But image recognition software, as amazing as it is, lacks some of the key features of human-like intelligence. For example, it lacks the ability to learn on its own without human supervision. At least, that is the case at the time of creating these lessons. Image recognition systems do not yet learn on their own. So then, how intelligent is this AI actually? This brings us to the key question about what intelligence is. How do we measure intelligence? At what point can we say that an AI system exhibits human-like intelligence? Answering the question of what intelligence is beyond the scope of these lessons, and the type of intelligence tests that we've used to measure the intelligence of machines has evolved over time. For example, at the time of creating these lessons, which is May 2023, ChatGPT is all the rave, and right now, everyone is in awe of its capabilities. ChatGPT would have passed Alan Turing's test for intelligence back in the 1950s. Alan Turing was, or is, considered to be the father of theoretical computer science and AI. But our measures for machine intelligence have changed over the years, and at this point in time, I can guarantee you that as powerful and as amazing as ChatGPT is, there is no real human-like intelligence involved whatsoever. I'll touch on this a bit more in the upcoming lessons. So, the term AI has become this general, all-encompassing term that people use very loosely. A term that we use even in situations where there's no real intelligence involved. We use the term AI when we talk about the broader field of computer science, where computers and machines can perform tasks that require human-like intelligence. But when we are talking about machine learning, we now start becoming more specific. We move from the generality of the term AI to a more specific, specialized subfield within the realm of AI. Machine learning specifically deals with how machines learn, without them being explicitly pre-programmed. Now, given that I've just said that AI systems do not yet have any real intelligence, you may well be thinking that I'm becoming too philosophical, theoretical, or perhaps even subjective or opinionated. And perhaps I am, but I'm bringing this up now because it has a direct bearing on the upcoming lessons where we discuss the ways in which machines learn. Without spoiling the fun for the next few lessons, the three main ways in which machines learn are supervised learning, unsupervised learning, and reinforcement learning. In the upcoming lessons, you will see that for supervised and unsupervised learning, machines are pre-trained, and that human supervision is required during this training process, to a greater or lesser extent. However, with reinforcement learning, a machine is able to learn by itself. In contrast, the seemingly intelligent image recognition software I talked about earlier is trained to recognize images through a process of supervised learning. During this supervised learning process, the machine is trained by giving it thousands of images and told what each of those images are. And this is how it learns. After it is trained, it uses what it has learned to recognize other similar images that were not included in its original training dataset. Even ChatGPT is trained using a supervised learning methodology. With reinforcement learning, on the other hand, no training data is provided during the learning process. In this type of learning process, the system is given a goal or objective. That is it. For example, its objective could be to learn how to play and win the game of chess. The program then learns how to reach its objective, solve a problem, play a game, drive a self-driving car, or make a robot walk or dance. It does this all on its own, without you telling it how to reach this goal. Reinforcement learning is on a whole other level when compared to supervised and unsupervised learning, and the learning process is significantly more complex. You very likely will not be able to appreciate the significance of the difference between these machine learning methods just yet, but we will go through this in more detail in our upcoming lessons. You will see that what you can achieve with reinforcement learning is nothing short of mind-blowing. For now, just keep it in the back of your mind that systems that learn using the reinforcement learning process probably mimic human-like intelligence more closely.